Hello, everyone, and welcome to Precalculus. This is section 10.7 on polar coordinates. This is a very cool section. Formerly, we used a rectangular coordinate system for graphs of equations involving ordered pairs, x, y. Today, we will learn how to use a polar coordinate system where the polar coordinates are r, comma, theta. I actually think it's easier to plot theta first, but that's the order that they're given in. So r is the directed distance from 0 to p, and theta is the directed angle counterclockwise from the polar axis. So instead of the x-axis, we're going to call this the polar axis, to the segment OP. So we'll just jump right into an example, and I think it'll help you see it. But before we do an example, let me just go ahead and label this polar graph for you. You may remember that these are in twelfths. So this first one is 1/12, but we don't usually use that one. So we're going to jump to 2/12, which reduces to pi6, and then 3/12, which reduces to pi4, and then 4/12, that reduces to pi3. This one would be 5/12, and then pi halves. And then over here again, skipping that one, we have 2 pi3 and 3 pi4 and 5 pi6 and pi, 7 pi6 and 5 pi4 and 4 pi3 and 3 pi halves. Finally, in quadrant 4, we have 5 pi3, 7 pi4, and 11 pi6. That'll make our work go faster having it pre-labeled. So 2 pi3. So I'm going to go to the pi3 angle, and then I just go 2 rings out. So it's right there. I am going to label it number 1 because there's going to be a bunch of dots in a minute. Then I have 6 negative pi6. Remember that a negative just means you go counterclockwise. So I'm going to go pi6 in this direction. And once I'm on my angle, I just count the radius. So 1, 2, 3, 4, 5, 6. It's really far out there. Okay, this is the first new one. This one's a little bit unusual. So I am going to go to my 11 pi6, which is actually just where I was a minute ago, but it says -4. The negative means that you go backwards from what you were planning on doing. So instead of it being 1, 2, 3, 4 this way, it's just going to be 1, 2, 3, 4 this way. And then on this one, I go to the -2 pi3. Again, remember that just means counterclockwise. So I go to -2 pi3, so it's somewhere on this line. And then I go out 3. 1, 2, 3. And this one is number 4. I forgot to label this one 3. And last, 2 and -pi6. So -pi6 is this way, but it's only 2 out. And that's how you plot them. It's very straightforward. Now, in the Cartesian coordinate system, which is rectangular, each ordered pair is unique, but that is not the case in the polar coordinate system. So think about the point 3, -3/4. So I'm going to go to -3/4, which is going to be over here. If you want to relabel your whole graph, you can, that's fine. But it's -3/4, and I'm going to go out 3. 1, 2, 3. But somebody else might have said, well, you went this way, but what if I had gone counterclockwise? Then this would have been 5 pi4. And they are absolutely right. This is the exact same angle as 3, -3 pi4. There's actually 2 more, because somebody might just go to pi4, which would be right here, this line, but then do -3, and that would also land them there. And then as another possibility, which would be pretty unusual, they could do -7 pi4 to get all the way over to here, and then do the -3. So -7 pi4 would put us on the pi4 line, but then the -3 would flip us to the other side. So all of these answers are exactly the same as the original one given. And that is something we don't have in the rectangular system. See if you can do the next one on your own. So 5 pi halves is bigger than 2 pi. So 2 pi is 4 pi halves. So that means I've already gone around once plus another half. We call these coterminal. But then even though I'm on this line, this is the one I'm looking at, I want to use -1, so I'm actually going to flip to the other side. There's my point. And now you just have to think of now that you know where it is, you just have to think of a bunch of other names for it. So I could do -pi halves and 1. I could do 3 pi halves. That would be the same. And 1. I'm going to ask you to do one with a negative. So to do -1, I'd actually want to land at pi halves. Because if I'm up here and I say -1, that would flip me to the other side. And then if you wanted a fourth one, you could do -3 pi halves, which would put you up at pi halves, and then -1. So there's lots of choices for that. So we do need to learn how to convert from rectangular coordinate system to polar and vice versa. So I've done kind of a strange thing. I've overlaid two graphs on top of each other just so you can see how they relate. So let's say I have the point 2 comma pi. So pi is this line right here, and I want to go out 2 on the circle. So it's right there. So it looks like I know the circle didn't fall exactly where I wanted it to, but it's pretty close. So it looks like it's just the point -2 comma 0. Well, sometimes you're going to be able to just look at it and know it, but sometimes you're not. So what my goal is to help you learn these two formulas so that you can do that. So polar to rectangular. So let's say I couldn't, or let's just say you didn't graph it, which a lot of people don't bother to do. It's as easy as using a formula. X is r, which is 2, cosine of theta, which in this case is pi. Cosine of pi is -1. And so just like you would have expected, 2 times -1 is -2. To get the y coordinate, I do r again, but this time I do sine of theta, which for us is pi. Sine of pi is 0, so 2 times 0, and sure enough, that will give you that. So I personally do both. I use the formula, but then I also graph it to see if my answer sounds correct. This one, square root of 3, which is approximately 1.7, and pi 6. So I'm going to go to my pi 6 line. This one's pi 6. And I'm going to go out about 1.7. So it's somewhere out there. So I don't know exactly what this number is, so I'm going to use my formula. X is equal to r cosine theta. So interestingly, cosine of pi 6 also has a square root of 3 in it. So this becomes the square root of 3 times the square root of 3 over 2. When you're multiplying fractions, you can go straight across the numerator and straight across the denominator. And that gives me 3, because it's the square root of 9, over 2, which is 1.5. So I look at that, and do I think I'm about 1.5 out? I definitely am. I'm feeling really good about that answer. And for the y, I'm expecting something a little less than 1. It doesn't look like I made it up to 1, so let's see what we get. Square root of 3 sine of pi 6. So sine of pi 6 is 1/2. When you're trying to multiply a whole by a fraction, you can make the whole into a fraction, and then you multiply straight across the top and straight across the bottom. So you're allowed to write this as square root of 3 over 2. You don't have to convert it. But just so you know, this is approximately 0.866, which sure enough is a little less than 1. So I feel very confident in that answer. There's another one. You might want to try this one on your own. But of course, I am going to do it for you. So this time I'm going from a rectangular to a coordinate, but it's the same thing. There's a formula at the top of the page. So -1, 1. It's right here. So I better get a quadrant 2 answer and an r that's between 1 and 2. So let's use our formula. It says tangent of theta is y over x. So tangent of theta is going to be y over x. Now, of course, remember, when you're given the ratio and you need to know the angle, you have to use inverse tangent. So inverse tangent of -1 is -pi4. Remember that tangent can be equal to -1 in two different places, in quadrant 2 or in quadrant 4. Now, your calculator has been designed to always give you the quadrant 4 answer. But since it is possible that it's in quadrant 2, it's up to you to figure that out. So this is actually not going to be our answer. Our answer is going to be 3 pi4, which is the quadrant 2 answer. So you have to think about it at this stage. When is tangent equal to -1? At pi4, or at -pi4, or 3 pi4. But clearly, if you graph it, you'll see which one you want. And then to find the r, the formula we're going to use is r squared, to the top of your paper, is equal to x squared plus y squared, which means that r squared is going to be equal to -1 squared plus 1 squared. Now, if you're doing this on your calculator, which would be a little sad, sorry, and you don't bother to put the parentheses in, you just do -1 squared plus 1 squared, your calculator is going to do order of operations, which means it's going to do exponents before subtraction, and you're going to get an r of 0. I get this all the time. Clearly, the r is not 0, so it means you've made a mistake. Well, I'm telling you where that mistake probably is. It's right there with that parenthesis. So this becomes r squared is equal to 2. R is the square root of 2. Now, technically, when you do r squared is equal to 2, you get r is equal to plus or minus the square root of 2. But for our purposes, we want it to be positive if we're going to use the 3 pi4. If you'd like it to be negative, you could do negative square root of 2, but then you'd have to go down here to -pi4. So there is a little bit of thinking involved in these answers. This is going to be the most common one, and the one that's probably given. Okay, let's do the next one. 0, 2, 0, 2. Now, if you graphed that, you really don't have to do any of this work. You can just look at that and say, oh, well, clearly that's 2, pi halves. So I'm going to try and reward you when I can for actually bothering to make the graph. But just to show you that it'll still work if you choose to do it the long way. So tangent of theta is equal to y over x. Tangent of theta is equal to 2 over 0. You can't divide by 0. So when is tangent undefined? At pi halves and at 3 pi halves. But ours is clearly the pi halves. And then r squared is equal to x squared plus y squared, which means r squared is equal to 0 squared plus 2 squared. So, of course, r is equal to 2. So we would have gotten the answer even if you hadn't graphed it and just looked at it. But I'm always trying to encourage you to look at your answers and see if they make sense. Now that we've converted points, we're going to convert entire equations. And going from rectangular to polar, you simply replace x by r cosine theta and y by r sine theta. But converting from a polar to a rectangular is definitely going to require some thinking on your part. It's a little bit harder. So let's do the easy ones first. So I'm just going to replace y with r sine theta, just like we talked about, and in the last section. And then x is going to be r cosine theta, but it is squared, and you can distribute that square. So now I have r sine theta is equal to r squared cosine squared theta. So we're just going to get r all by itself like we always do. So I'm going to divide both sides by r, and that gives me sine theta is equal to r cosine squared theta. and then I divide both sides by cosine squared theta. And I get r is equal to sine theta over cosine squared theta. Now, of course, we learned some trig identities. You could clean that up a little bit. Sine over cosine is tangent, and then cosine on the bottom is a secant on the top. That would be the same. It doesn't matter. So this we know is just a nice basic parabola, but if you wanted to make that parabola happen on a polar coordinate system, you'd have to do this equation, which is a little bit crazy. Now we have x squared plus y squared is equal to 16. So again, I'm going to change it to r cosine theta squared plus r sine theta squared is equal to 16. I can distribute the square because it's multiplication. You cannot distribute a square when it is addition. And then I am actually going to factor out the r squared, which gives me cosine squared plus sine squared. Does anybody see it yet? Come on. This is 1. Remember that? I know it was a couple chapters ago. You can do it. So r squared is just equal to 16. So r is equal to, now technically plus or minus 4, but we're just going to write r is equal to 4. Now think about that. What does that mean? If there's no theta and r is 4, well, that would imply that r is 4, but theta is 0. Maybe theta is pi 6. Maybe theta is pi halves. Maybe theta is 3 pi fourths. Maybe theta is pi. Do you see where I'm going with this? It's not going to come out very nice, but it makes a circle. And that's what this is. This is a circle. So unlike the last one, where y is equal to x squared is so easy to make a parabola, and this would be really complicated, this one is where polar coordinates really shine. Just by saying r is equal to 4, you've got yourself a circle, where we always had to learn it as x squared plus y squared is equal to 16. Okay, let's do another one. This is a line, right? We could rearrange it with to get y all by itself on one side. What did your gut say? Is a line easier to graph on a rectangular system or on a round system on a polar coordinate system? I'm thinking it's going to be easier on a rectangular. But let's plug things in. Remember that you're going to just replace x with r cosine theta, and you're going to replace y with r sine theta. I'm going to move that 2 to the other side. Again, factoring out, whenever you have a variable twice, and that's the variable you're trying to solve for, you can make it into a single variable just by factoring it out. And once you've factored it out, then whatever's left next to it, you can remove by division. So 3 cosine theta plus 5 sine theta. This is what would make a line, how you would have to do it to make a line on a polar coordinate system, which is, by the way, section 10.8. So we'll do that next. Okay, here we go. A little bit harder. So your formula that you know is r squared is equal to x squared plus y squared. Keep that in mind. So if you just have an r, you're really kind of stuck. So I'm going to change it to r squared. Now that I have r squared, I can change it to x squared plus y squared. And that's how you can get the equation into rectangular form. And of course, we know that it's a circle because we just did one a little bit ago like that. Okay, this one is a little weird, right? Just theta is equal to pi thirds. So again, you have to ask yourself, how can I change that to something that I know? Well, this is a little bit tricky, but remember that tangent of theta is equal to y over x. That was in your conversion formulas there. Let's just go back. Okay, so we've already used this one. Now I'm going to use this one. But it's not obvious though. Unlike before, where just every time you see an x, change it to r cosine theta. And every time you see a y, change it to r sine theta. Now you're going to have to make it look like one of these. So we did that the first time by squaring the r, and this time we're going to do it by taking tangent of both sides. And then I can replace tangent with y over x. And I actually know this. Tangent of pi thirds is the square root of 3. And now all rectangular systems, we solve for y. So I can write that as y is equal to the square root of 3x. What is that? It's a line with a slope of the square root of 3, and it passes through the point 0, 0. And if you think about it in polar terms, it's a line because it's just the pi thirds line. It doesn't say anything about r. So r might be 1 or 2 or 3 or 3.5. It could be anything. So by them saying theta is equal to pi thirds, it makes sense that it's a line. And it's a line whose slope is the square root of 3, because that would be tangent. So like I said, I know that these are a little tricky. Your first instinct might be to square it. That's what we did last time we saw an r. But on this one, first, let's change that to cosine. And now let's clear the fraction. Do you see what's going to happen if we do that? So we get r cosine theta is equal to 1. And now you have to recognize that. What is r cosine theta? It's x. So x is equal to 1. So this represents a vertical line at 1. Okay. All right. D, E, and F are literally exact duplicates of what I've just done. So I really would stress that you should try them on your own. But of course, I am going to do them for you. So the first one, you can square both sides. And you get r squared is equal to 1. You can replace the r squared with x squared plus y squared. And there you have your formula. X squared plus y squared is equal to 1. On this one, you need it to be tangent of theta in order to change it to y's and x's. So I take tangent of both sides. On this side, now I can make my replacement, y over x. And on this side, tangent of pi fourths is 1. I clear the fraction to get the y all by itself on one side, and I get y is equal to x, which makes sense because y is equal to x is just a line through 0, 0 with a slope of 1. And isn't that exactly where pi fourths is? So hopefully the answers are at least making sense, even if they're a little bit more challenging. And just to show you that squaring both sides to get r is not always what you want to do, on this one, I would change this to 1 over sine theta, and then I would clear my fraction, multiply both sides by sine of theta, and I get 1 is equal to r sine theta being r sine theta being y. So y is equal to 1. So this represents is how you would make a horizontal line at 1. But actually making the graphs will be section 10.8. All right, that's it for 10.7. Have a great day.